From Saturn's dazzling bands to Neptune's faint arcs, rings are some of the most beautiful features in our solar system. But if you look inward, Mercury and Venus have nothing? Why? Rings are usually made from icy particles, dust, and rocky debris, held in place by a planet's gravity. Gas giants like Saturn and Jupiter have the massive gravitational pull needed to trap and maintain these rings for billions of years. Their immense gravity creates a stable environment far from the destructive forces of the sun, allowing vast collections of ice and rock to form the spectacular systems we see today. The further a planet is from the sun, the colder its environment, which is crucial for preserving the icy components that make up the most brilliant rings. Saturn's rings, for instance, are 90 to 95% water ice, a material that would not survive in the inner solar system. These giants also possess numerous moons, which play a critical role as shepherd moons, using their own gravity to help confine the ring particles into narrow, well-defined bands and prevent them from dispersing into space. This combination of massive gravity, vast distance from the sun, and a complex system of moons creates the perfect cosmic recipe for long-lasting, magnificent rings. The gravitational influence of these planets is so dominant in their regions of space that they can capture passing comets or asteroids, break them apart through tidal forces, and add the resulting debris to their existing ring systems, constantly replenishing and reshaping them over geological time. Jupiter, Uranus, and Neptune all have rings, though they are fainter and less substantial than Saturn's, each telling a unique story about its planet's history and gravitational environment. Mercury and Venus, on the other hand, face two big problems. First, they're too close to the sun. Any icy material would simply vaporize, while solar radiation and tidal forces would scatter dust and rock before rings could form. Imagine trying to build a delicate ice sculpture right next to a bonfire. It simply wouldn't last. The intense heat from the sun in the inner solar system means that any water ice, a primary ingredient for bright, reflective rings, would sublimate directly into gas and be blown away by the solar wind. Beyond just the heat, the sun exerts a tremendous gravitational pull and emits a constant stream of charged particles known as the solar wind. These forces are incredibly disruptive. The sun's gravity would exert strong tidal forces, pulling on any potential ring material and stretching it out until it either falls into the planet or is ejected from orbit. Furthermore, the solar wind acts like a constant sandblaster, pushing lighter particles like dust and small grains out of orbit and scattering them across the solar system. This effect, combined with a phenomenon called the Poynting-Robertson effect, where solar radiation causes dust particles to spiral inward toward the sun, makes it virtually impossible for a stable ring system to persist around the inner planets. For any significant amount of time, any collection of debris would be stripped away almost as soon as it formed, leaving Mercury and Venus perpetually bare. The environment is simply too chaotic and hostile for the delicate dance of gravity and orbital mechanics required to maintain a planetary ring. Second, their gravity isn't strong enough to hold on to debris for long. Even if an asteroid impact or captured comet created a temporary ring, it would quickly be lost. Unlike the gas giants, which have masses hundreds of times greater than Earth's, Mercury and Venus are much smaller terrestrial planets. Their gravitational fields are consequently much weaker. A planet's ability to hold on to a ring system depends on a region of space around it called the Roche limit, the distance within which a celestial body held together only by its own gravity will disintegrate due to a second celestial body's tidal forces exceeding the first body's gravitational self-attraction. While rings must form inside this limit, they also need to be far enough from the planet to avoid being dragged down by its atmosphere. For a small planet with weak gravity, this stable zone is extremely narrow. Any material that might form a ring would be subject to a constant tug-of-war between the planet, its weak pull, and the overwhelming gravitational influence of the nearby sun. Even a slight perturbation from another planet or a passing asteroid could easily knock the debris out of its fragile orbit. If a moon were to be shattered or an asteroid captured, the resulting debris cloud would be unstable. Some of it would likely fall onto the planet, some would be flung out into space, and the rest would be quickly swept away by the solar wind and radiation pressure. The planet's gravity just isn't a powerful enough anchor to withstand the constant disruptive forces present in the inner solar system, making any potential ring a fleeting, temporary phenomenon at best. Venus has an additional challenge: its thick atmosphere. Any ring material near the planet would experience drag and spiral down to the surface. While Mercury is an airless world, Venus is shrouded in an incredibly dense atmosphere, about 90 times thicker than Earth's. This crushing blanket of gas extends much further into space than our own atmosphere. For any ring to be stable, its particles must orbit above the tangible reach of the atmosphere to avoid friction. However, for a planet like Venus, the region where a ring could theoretically be stable inside, the Roche limit significantly overlaps with the upper layers of its extended atmosphere. This means that any particles of rock or dust orbiting close to the planet would constantly collide with atmospheric gas molecules. Each collision, no matter how small, would rob the particle of a tiny bit of its orbital energy, causing its orbit to decay. Over time, this cumulative effect of atmospheric drag would cause the ring particles to slow down and spiral inward, eventually burning up like meteors as they plunge deeper into the dense Venusian clouds. This process would effectively act as a planetary vacuum cleaner, sweeping the near-planet space clear of any debris. So even if Venus could overcome the challenges of the sun's heat and gravity, its own suffocating atmosphere would deliver the final blow, ensuring that no ring could ever hope to survive. The planet's atmospheric grasp is simply too strong and too far-reaching. The cosmic jewelry belongs to the outer planets. Mercury and Venus, despite being fascinating worlds, just don't have the right conditions to sparkle with rings. The inner solar system is a realm governed by the sun's immense power, a place where heat, radiation, and overwhelming gravity create an environment fundamentally hostile to the formation and preservation of the delicate, icy structures that adorn the gas giants. For a planet to wear rings, it needs to be massive, cold, and distant from the sun's disruptive influence. The terrestrial planets meet none of these criteria. Their smaller size gives them a weaker gravitational grip their proximity to the sun subjects them to. Intense heat and radiation that would vaporize and blow away ring material, and in the case of Venus, a thick atmosphere, actively works to drag down any orbiting debris. The stark difference between the ringed giants and the bare inner planets is a powerful illustration of how a planet's location and physical characteristics dictate its appearance and evolution. The beautiful, intricate ring systems of the outer solar system are a testament to a delicate balance of cosmic forces of balance that simply does not exist closer to our star. Next time you look at Saturn's rings, remember, they're not just beautiful, they're rare. And Mercury and Venus remind us that in space, conditions decide everything.
Stay curious.